Good evening, folks. Today we're going to discuss how we measure mass. In former lectures, we discussed matter. And one of the things scientists like to do with matter is they like to measure it. They measure it because they like to use it to compare to other types of matter and see the differences and similarities amongst them. Okay. The piece of equipment we use to measure matter is called a triple beam balance. The triple beam balance helps us determine how much matter is in a particular object, meaning how many atoms and molecules give mass to that object. Okay? The units that mass is measured in, if you recall, are called grams. You'll remember that in the metric system we use grams to measure mass. So the triple beam balance will measure objects placed on it in grams. The triple beam balance may look like a scale to you, but it's not. A scale measures weight, and weight is not mass. So weight is measured in different units. Weight is a measure of the Earth's gravitational pull on an object or person, and it is expressed in units called newtons. So weight is not mass, because mass is expressed in grams. All right? Weight is measured in newtons. Remember, mass is a measure of how much matter something contains, or how many atoms and molecules are in it. Weight is a measurement of Earth's gravitational pull on an object. Here we have the parts of the triple beam balance. You have the measurement tray. This is where you're going to put any objects you want to determine the mass of. All right? When we want to determine the mass of an object, some labs will refer to as massing out the object. It'll tell you, go mass out the object to determine the mass. Okay? Over here you have the pointer and the 0 mark. Before you put anything on this measurement tray, you want to make sure that this pointer and that 0 mark are matched up exactly, or as close together as possible. If they are not matched up, you should make sure all the riders, now these are the weights, there's 3 riders on our triple beam balance, and all these weights you have to make sure are set to 0. And then you're going to check the pointer and make sure the 0 mark and the pointer are matched up. If once you checked all the riders, they're all set to 0, and the pointer and the 0 mark are still not matched up, you have to turn the adjustment knob. So if the pointer is above the 0 mark, you're going to rotate the adjustment knob towards you. If the pointer is below the 0 mark, you're going to rotate the knob away from you. Okay? When you do this, you should do it one full turn at a time. And then let go of the balance and see if the pointer matches with the 0 mark. Now, when you are checking the 0 mark, you want to make sure that you are looking at it at eye level. So your eye should be level or even with the pointer and the 0 mark. If you are looking at the pointer and the 0 mark but from above it or below it, you are not getting an accurate measurement. So once the pointer matches the 0 mark, it is time to figure out the mass of our object. We will do this by moving the riders. So when it's time to figure out the mass, once you find it set to there, you're going to place the object on your measurement tray, and then you're going to move the riders. You're going to start with the largest rider. There's a 100-gram rider in the middle usually. Behind that, you have a 10-gram rider, and here you have a 1-gram rider. In between the 1-gram riders, you'll see a bunch of little hashes, and there's 10 little hashes between each one of these marks on your 1-gram rider. And each one of those hashes is equal to 0.1 grams. So once we've placed the object on our measurement tray, it's time to move the 100-gram rider to the right towards the 500-gram mark on our triple beam balance. You're going to move it up 100 grams at a time until the pointer drops. So once you move that rider and that pointer drops, you realize that you've gone too far, so you have to move it back 1. So if you went to the 300 mark and it dropped, you know that the object on the measurement tray is less than 300 grams, but it's greater than 200 grams. Now, you're going to do the same thing for the 10-gram rider. You're going to move it 10 grams at a time until the pointer drops. If you got to 70 and it drops, you went too far. So you know that you have to move it back 1. So it's greater than 60 grams, but less than 70 grams. You are then going to do the same thing for the 1 gram weight. This gets tricky because the goal is to be as precise as possible. So you have to slowly move the 1 gram weight to each little 0.1 gram mark. What I usually like to do a little bit quicker is I'll move it down to the 5 gram mark. And if it drops, I know it's less than 5 grams. If it doesn't drop, I know I have to go up for more. So then I'll move it to the 9 gram mark. And then I move it back. And if it goes back up at 7, you know that your object is greater than 7 grams here. Okay? So it's somewhere between 7 and 9. That's when you start moving it up, one little hash at a time, so you get an accurate measurement. Okay? Once it matches, and that pointer is even with the 0 mark, you can record your measurement with a decimal. So your measurement might be something like we said here, 277.4 grams. Once you have that number, you can record it down in your data table. You're not done yet. Now you have to reset the triple beam balance to 0 again and make sure that pointer is at the 0 mark. You're going to take the object off the tray and you're going to reset everything to 0 and make sure the pointer and the 0 mark match up. If they don't, you're going to have to turn the adjustable knob accordingly. If it does match, you're in luck. You could simply put the object back on the tray and mass it out again. You're going to do this 3 times. You do this 3 times so that you make sure you didn't make an error. Once you have the 3 measurements in your data table, you're going to add them together and divide by 3 and get the average mass of that object. So you'll end up having 3 numeric measurements. Once you have those 3 measurements, you're going to add the 3 together and you're going to divide the total by 3 and you're going to give yourself your average mass in grams. So you should have a unit next to all of these. How do we read the riders? If we are reading these riders, you would see that this large rider goes to the 300 gram mark. So you have a 300 gram object, but it's greater than 300 grams because you have the 10 gram rider going out to the 70. So it's 370. And then you see the 1 gram mark at the 3. So it's 373. But the center, that arrow, is not lined up exactly at the 3. It's slightly greater than the 3 on the 1 gram rider, but it's less than 4. This mark right here is the halfway mark. So that would be 373.5 if it were there, but it only goes to the 1, 2, 3, 4. So it only goes to the 4th hash after the 3 on the 1 gram rider bar. So the mass of whatever object was on this balance over here is equal to 373.4 grams. Okay? So that's how you would read that. If you have any questions, please feel free to ask as we walk around the room. Have a good night.